have a continuous function on a line segment, so we know that it takes its global extrema. The first thing to do is to figure out the equation for the line that contains these 2 points. And to do that, we draw a picture. So we have a coordinate system, and the first point is at 0, -1, and the second point is at 2, 5, and this is the line that contains them. So you can see that if you move 2 units to the right, you also move 6 units up, and this means that the slope of the line is 3. So you have that y is equal to 3 times x plus something, and here you can see that this line intercepts the y-axis at -1. This means you have to subtract 1 from here, so the equation will be y is equal to 3 times x minus 1. And you know, because you only have a line segment, you are only considering this part of the line, and this means that x is inside the interval 0, 2. So you have figured out a formula for y, and you can plug that back here. We have f of x comma 3 times x minus 1, and this is x squared minus x times 3x minus 1 plus 3 times 3x minus 1 squared. And you can calculate this. This will be x squared minus 3x squared plus x plus 27 times x squared minus 18 times x and plus 3. Now you can combine similar terms, so this will be 25 times x squared minus 17 times x plus 3. And as you can see, now you only have one variable in this expression, and this means that this is a function of one variable. So this will be g of x, and don't forget that x must be between 0 and 2. So you know that one variable function on a closed and bounded interval takes its global extrema at an inner critical point or at the endpoints. Well, we can calculate the derivative to find the inner critical points, but you can see that this is just a quadratic function, so we can just draw its graph. Because this is positive, we know that this will be a smiling face, so its graph will look something like this. And we also know that the place of its minimum value is at minus b over 2a, which is in our case will be 17 over 15. And this is good for us because 17 over 15 is inside this interval, so this is the element of 0, 2. We also can draw the image of this interval, and this will look something like this. So you can see that 17 over 50 is closer to 0 than it is to 2, and that's the reason why the image is something like this. And from this picture you can see the minimum and maximum places, but we also have to calculate the minimum and maximum values. So the minimum value will be at x equals to 17 over 50. So let's calculate g at 17 over 50, and this is 25 times 17 over 50 squared minus 17 times 17 over 50 and plus 3. So this is the minimum value, and the maximum value will be at 2, so we also have to calculate g at 2, and this is 25 times 4 minus 17 times 2 and plus 3, and this will be the maximum